Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we're going to start with chapter 12, statistics, permutation, and combination. Before we go deep in statistics and the probability combination and the permutation, I have to go to some terminology and some concept or some term that you have to note. The first one is a sample space. What is a sample space? A sample space is a list of all possible outcomes of an experiment. For example, if you are choosing a coin, it just maybe head or tail. So this is the sample space. Or if you are rolling a dice, so maybe you got 1, 2, 3, 4, 5, or 6. So this is the sample space for rolling the dice. The event. An event is what you're looking for. For example, I'm asking you, what is the probability or event A getting an even number? For a die, how many even number you have? 2, 4, 6, because the die is just only from 1 to 6. So 2, 4, and 6, these are the events for the even number. What about the odd numbers? Could be 1, 3, and 5. Okay, maybe getting ahead when you toss a coin, it's only one event to get ahead. So the event is part of the sample space. Now, what is the meaning of probability? Probability tells you how likely an event is to happen. And it's always number between 0 and 1. So the formula for it, favorable outcomes over the total outcomes. Let me give you an example here. There are 4 red apples and 6 green apples in a box. What is the probability of choosing a red apple? Now, how many red apples you have? It's 4. What is the total of apple? 4 plus 6 give you 10. So it means it's 0.4 or equal 40%. As you see, it's between 0 and 1. So the probability of event is the favorable outcome over the total outcome, part over the total. The counting principle. When you make choices in steps, multiply the number of options in each step to find the total number of outcomes. For example, you have 3 shirts and 2 pants. How many outfits you could have? So I'm just gonna multiply 3 times 2, give me 6 outfits. Now, if you are rolling the dice 2 times, or sorry, you are rolling 2 dices, the first die will give you 6, and the second die will give you also 6. So 6 times 6 give you 36. The arrangement around the circle. I need to find how many ways I could arrange people around the circle or around the table. We have 2 ways, without a reference and with a reference. For without a reference in a circle, rotating the same people gives the same arrangement. It doesn't matter. Okay, so we fix one person and arrange the rest. So the formula for this is n minus 1 factorial. What is the meaning of factorial? When I say 3 factorial, this means I have to multiply all of the numbers before the 3. So 3 times 2 times 1. So it gives me 6. If I say 5 factorial, it would be 5 times 4 times 3 times 2 times 1. So 20 times 6 give me 120. Okay? So the formula for without a reference, n minus 1 I. So for example, 5 people around table. Okay, so 5 people, so 5 minus 1 factorial. So it's 4 factorial. So 4 times 3 times 2 times 1. So 4 times 3, 12. 12 times 2 give me 24 ways. Now, if we have a reference, so if someone has a fixed position, like the head of the table, like your father is sitting on the head of the table, then it's not like arranging people, it's just like arranging people in a line, okay? So I'm just gonna say n factorial. So I'm gonna say 5 factorial. So it would be 5 times 4 times 3 times 2 times 1 equal 120 weight. So again, for arrangement of the circle, you have a reference or without a reference. Without a reference, so it's n minus 1 factorial. With a reference, it's just n factorial. Now, for permutation, The permutation means arrangement when the order matters. For example, you are in a race and you have the first place, the second place, and the third place. Or you're getting a trophy, so you got the first trophy and you got the second trophy and the third trophy. So the arrangement here matters and the order matters. So the rule for it, it's n factorial over n minus r factorial. For example, how many ways to give the first and the second and third place to 5 students? Let me apply it here for you. So here, 5 students, so 5 factorial, and n minus r. What is r? How many object or how many person you're gonna select? I'm gonna choose 3 bills here. So 5 minus 3 factorial, it give me 2. So 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. As you see here, I'm gonna cancel 2 times 1 was 2 times 1. So 5 times 4 times 3. So it give me 60. So the permutation for this give me 60. Combination is when you're choosing item and the order does not matter. For example, the topping of pizza. It doesn't matter if you put mushroom first or you put in the jalapeno or you put in chicken or sausage. It doesn't matter, right? So the formula here is n factorial over r factorial times n minus r factorial, and r is the object that you selected. Okay, for example, let me try this with you here. How many ways to choose 3 students from a group of 5? So how many students you have, or the group is 5, and you selected how many? 3. So 5 factorial over 3 factorial multiplied by 5 minus 5 minus 3 factorial. So let me solve it with you here. So it's 5 times 4 times 3 times 2 times 1. And 5 minus 3, it's 2 factorial, right? So let me get here. 3 factorial is 3 times 2 times 1. And 2 factorial is 2 times 1. So let me simplify here. So 1 goes 1, 2 goes 2, and 3 goes with 3. So 5 times 4 is 20. 20 divided by 2 give me. So this means we have 10 ways. Okay, here, you know the scramble of the word? I'm giving you some letters and I'm asking you give me many words from this. Okay, so when you have a specific word and you need to know how many ways I could arrange the letter of this word, let me take the example for you here, success. Okay, so how many letters you have in success? 1, 2, 3, 4, 5, 6, 7. So 7. How many repeated letters you have? The S is repeated 3 times and the C is repeated 2 times. So if all letters are different, I'm gonna use this rule. N factorial, okay? If the letter is repeated, this means I'm gonna say n factorial over the repeated factorial. How many letters you have here? 7 factorial. And the S is repeated 3 times factorial, and the C is 2 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1, and 3 times 2 times 1, and 2 times 1. Let me simplify here. And the 4 divided by 2 give me 2. So 7 times 6 times 5 times 2. Okay, 6 times 5 is 30, 30 times 2 is 90, 90 times 7 is 720. So this is equal 720. So what is the probability of getting this word? It's 1 over 720. So again, if you have all letters are different, you're just gonna use this n factorial. But if you have some letters repeated, you're gonna say n factorial over the repeated letters. Let me give you another example to understand more. Now the word mass. Do you have any repeated letters here? No, it's just 4 letters. So it's 4 factorial. So 4 times 3 times 2 times 1. So it would be 24. So 1 over 24. Okay. Could be What is the number of a sample space element when rolling a dice twice? If you roll a dice once, you got 6. So 6 times 6. 6 times 6 give me 36. This is the counting principle. How many permutations are possible to form a 4-digit number using the digit 1 to 9 without repetition? Okay, here. So the permutation rule n factorial over n minus or factorial. So let me get it here. How many digits we have? So 9 factorial over 9 minus 4 factorial. So here, 9 factorial over 5 factorial. So this means I'm gonna cancel all of the numbers starting from 5 and before it. So it would be here 9 times 8 times 7 times 6. So I give you 3024. Now, what is the number of a sample space element when drawing 3 cards from 10 numbered cards without replacement? Okay, so I took 3 cards out of 10. So this he's asking me how many ways. So again, the permutation. So here it would be 10 factorial over 10 minus 3 factorial. So 10 factorial over 7 factorial. So this means I'm going to cancel everything started from 7. So it would be 10 times 9 times 8. So it would be 720. In how many ways can 5 people sit around a circular table? Do we have a reference? No. So it would be n minus 1 factorial. So 5 minus 1 factorial give me 5 times 4 times 3 times 2 times 1. So give me 120. If the letters of the word school are randomly rearrange it. Now let's me see how many letters we have. We have 6. Does anything here is repeated? Yes, we have letters. Letter O is repeated. So 6 factorial over 2 factorial. So it would be, of course, I'm going to cancel everything starting from 2. So it would be 6 times 5 times 4 times 3. So it give me, okay, this is 20. 20 times 3 is 60. 6 times 360. So 1 over 360. Now here, if the permutation of from n to 3 equal 120, what is the value of n bar 2? We apply the rule n factorial over n minus 3 factorial give me 120. Okay, if I try to solve this an equation and solve for n, it will take a lot of time. So I'll just try some numbers. So it would be a small number starting from 5 or 6, something like this. So let me try here. If I say 5 factorial over 5 minus 3 factorial. So here I'm going to cancel everything starting from 2. So it's 5 times 3 times 4. So this is not equal 120. This is 60. Let me try 6. 6 factorial. So 6 factorial over 6 minus 3. So I'm going to cancel everything starting from 3. So 6 times 5 times 4. Yes, it's 120. So n equals 6. Now he needs n bar 2. So 6 bar 2 give me 36. A box contains 5 blue pens, 3 red pens, and 2 green pens. What is the probability of drawing a red, then a green, then a blue pen in order without replacement? So here, what is the probability of getting a red pen? It would be 3. How many pens we have? 10. The total is 10 times. What is the probability of green? Green is 2 out of Actually, we took one of the bands, so I left with 9. Okay, then I have the blue 5 over. I took 2 bands, so I left with 8. 5 over 8. See this word without replacement. So let me simplify here. 1, 3, this is 5, and 5 here is 1 also. So it's 1 over 3 times 8 give me 1 over 24. The bag contained 4 green balls and 3 yellow balls. If 3 balls are drawn randomly, what is the probability that 2 are green and 1 is yellow? Good. As you see here, randomly means that the order does not matter. So I'm going to use the combination. And also, the rule for probability says that the probability equals the favorable outcomes over the total outcomes. Good. So this means I need to do the combination of it choosing 2 out of 4 times the combination of it choosing 1 out of 3 over the combination of choosing 2 out of 3. Choosing is 3 out of the total, which is 7. So let's do it. The rule of combination said n factorial, so 4 factorial over r factorial, so 2r factorial times n minus r. 4 minus 2 give me 2 factorial again. 4 factorial is 4 times 3 times 2 factorial over 2 factorial times 2 factorial. So here, 2 factorial cancels with 2 factorial, and it's 4 times 3 over 2 times 1. So give me 6. Let's get the combination 3, 1. So 3 factorial over 1 factorial times 3 minus 1 give me 2 factorial. So 3 times 2 factorial over 2 factorial. And here's 1. They cancel, so it's a 3 here. Let's get the combination here. So 7 factorial over 3 factorial times 4 factorial. The 7 is 7 times 6 times 5 times 4 factorial over 3 factorial times 4 factorial. And the 3 here is 3 times 2 times 1. Let me do it. Times 4 factorial. They canceled here. Let me simplify. 6 goes 6. So 7 times 5 give me 35. Now let's apply the rule here. 6 times 3 over 35. So it's 18 over 35. 2 men and 2 boys are standing in a row. What is the probability that a man stand at each end if they line up randomly? Okay, here, man 1, and here's man 2. Here's boy 1 and boy 2. Okay, they are standing in a row, so I need all of the possible ways they could arrange. What is the possible way of arrangement? It's factorial n factorial, right? So how many? It's 4 factorial, so 4 times 3 times 2 times 1 equal 24. These all the possible ways. As he's asking me about what is the probability that a man stand at each end. Okay, maybe this man gonna switch with this one or this gonna switch with this one. So I have 2 ways for the arrangement here. And the same for the boy. Maybe they're gonna switch. So this means here the probability is the favorable outcome over the total outcome. I have here 2 ways for men's and 2 ways for the boys, and the total here is 24. So 4 over 24 equal 1 over 6. Now let's go for geometric probability. What is the meaning of geometric probability? We use this when a point is chosen randomly in a shape, and this depends on length, area, or volume. So the rule here is that whatever is the geometric measure that you want, the variable want, over the total geometric measure. Let me give you an example here to understand. A square has an area of 16 centimeter, and a triangle inside it has an area of 4 centimeter. Let me draw it for you to understand it more. So the square 16 centimeters squared, and the triangle is 4 centimeter squared. And he wants, what is the probability that a random point fall outside the triangle? So he needs this part, the shaded area here. So first, I will get the shaded area. It's 12 minus 4. Give me 16 minus 12 minus 4 equal 12 centimeters squared. Now I'm going to apply the rule. What I need, it's 12 centimeters squared over the total area, which is 16. So 12 over 16 give you 3 over 4. It's very easy. Going forward, the probability of independent events. What is the meaning of independent? Events are independent if their outcome does not affect each other. For example, when you toss a coin or a rolling a die, you got head or tail. Or rolling a die, you got 1, 2, 3, 4, 5, 6. It doesn't depend on each other. Maybe having a boy or a girl, or when you draw some pins or draw some balls with replacement. All of these are independent events. So when you try to get the probability of all of these independent events, you just multiply its probability. So if the event does not change each other outcome, you just multiply the probability. What if it changed the outcome? If it changes the outcome, for example, you are drawing some balls, but without replacement. That you have like 6 ball reds and 5 balls green, and you are drawing red balls or green balls without replacing them or without putting them again in the box. This means that the outcome or the total will change. This means that while doing your probability, you have to change the outcome or the total. So if events are independent, we use multiplication. If events are dependent, we use the conditional rules. We will go for it now, or update the total. So make sure to update the total of if there is the word without replacement. This means that the total change. The complement rule, we already know that the total probability of all outcomes is 1 or 100%. So if I know that something will happen, the probability of it, I know it, and I need to know the probability of this thing will not happen. I will just subtract 1 minus the probability of this thing. So the probability of not happening this event is 1 minus the probability of A, or 100% minus the percentage of the probability. The union of events or this means that you're getting the probability of A or B. So I'm gonna give you an example and explain this rule about this example. So imagine you are rolling a die and you want to know the chance of getting the number less than 4 and also even number. So or here means you are interested in either of the events happening or both. Maybe less than 4, maybe even number, or maybe both. Okay, so here, so the less than 4 would be 1, 2, and 3, because the die is 1, 2, 3, 4, and 5 and 6. So less than 4, it would be 1, 2, and 3. For even, it would be 2, 4, and 6. Okay, so as you see here, there is a repeated number. It's counted twice, which is 2. So that's why I have to subtract it. So the rule now for the union is the probability of A plus the probability of B minus the probability of the intersection or the repeated objects or repeated item or the repeated number. So what is the probability of A? It's a 3/6, which is less than 4. What is the even number probability also? 3/6. And the intersection is 2, so it's 1/6. So 3/6 plus 3/6 minus 1/6 give me 5/6. So again, the rule for the union, probability of A plus probability of B minus the probability of the intersection. The conditional probability means we already know something happened and we want to find the chance of something else happening given that information. So here is it. The probability of A given B equal to the probability of A and B, the intersection, over the probability of P. So if I want A, I'm gonna divide the intersection by the probability of B. One of them needs the probability of B given A. So it would be the probability of intersection, A and B, over the probability of A, the given one. Question number 10. In a garden, 4 passes X, Y, Z, and W have lengths 4, 6, 10, and 20, respectively. If a gardener randomly chooses one pass to lay decoration, what is the probability it will be pass Z or W? Okay. So the total passes here, X plus Y plus Z, W equal 4 plus 6 plus 10 plus 20. So it's 40. And the passes Z and W, Z is 10 and W is 20. 10 plus 20 give me 30. So the probability would be 30/40, give me 3/4. Square has an area of 16 centimeters square and a triangle inside it has an area of 4 centimeters. What is the probability a randomly chosen point in the square falls in the shaded region outside the triangle? I already explained this before, but let me explain it again. Here is a square, and here is a triangle, 4 centimeters. And he's telling you what is the probability of the point to fall outside the triangle. So I will get the shaded area first, which is 16 minus 4, give me 12 centimeters squared. So the probability is 12 over the 16. So it would be divide here by 4. 3 divided here by 4. So it's 3/4. What is the probability that a family has 2 girls followed by 1 boy and 3 consecutive births? Okay. Are these dependent events or independent? They are independent. Getting girl or boy doesn't depend on each other, right? So what is the probability of getting girl? It's 1/2. And what is the probability of getting a boy? It's also 1/2. Right? Good. So I will multiply the probability, but he say 3 consecutive births, so 2 girls and 2 boys. Huh? The probability here would be 1/2 for the first girl, 1/2 for the second girl, and 1/2 for the last boy. So it would be 1/8. A box contains 4 green balls and 2 yellow balls. If 1 yellow ball is drawn without replacement, what is the probability that the second ball is drawn is also yellow? Okay. The total number of balls, 4 plus 2, is 6 balls. Good. And he say without replacement. So this means I have to change the total, right? While doing the probability. Now he draw 1 yellow ball, so the left balls would be 5, right? So the probability of getting a yellow again it would be how many? I already draw one ball, so it's 1 yellow over how many? 5. If the probability of snow is 40%, what is the probability that it does not snow? So all of it is 100. So 100 minus 40, 100% minus 40, give me 60%. Based on the table below, what is the probability that someone did not train and lost? The total first is 10 plus 5 plus 4 plus 6, give me 25. So the total is 25. Okay, did not train, 6. Not train and lost, 6 over 25. So the answer is 6 over 25. Standard die is rolled. What is the probability of getting a number less than 4 or an even number? So this is union, right? What is the rule of the union? A union B plus the probability of A, first element, plus the probability of B minus the probability of intersection. So what is the probability of A? How many numbers less than 4 is 3? So it's 3 over 6. Because the total is 6 on the die. So 3 over 6. What is the probability of getting even number? 2, 4, 6. So it would be also 3 over 6. And if you see here, it's 1 and 2 and 3 and 2 and 4 and 6. We have here repeated 2, right? So it's 1 over 6. So it's 3 plus 3, you 6 over 6 minus 1 over 6 give you 5 over 6. In a class of 50 students, 22 take English and 28 take history and 10 take both. What is the probability of a randomly selected student take English or history? Again, we're going to apply the rule of union. So B of A intersect B, sorry, union B. Section of A and okay. Now, the first event, the one who take English. Okay, good. How many? They're taking English. 22 out of 50. How many take history? It's 28 out of 50. And the intersection between them is 10. So 10 out of 50. So here's the answer is 50 minus 10 give me 40 over 50. Now, 2 dice are rolled. What is the probability that the sum of the number on the top face is equal to 7? Okay, here, let me see. This is the first die. 1, 2, 3, 4, 5, and 6. And the second one here also is the same. So let me combine the number. If we add them, give me 7. So we have 1 and 6, 2 and 5, and 3 and 4, 5 and 2, also 6 and 1, and we got also this one 4 and 3. Okay, how many here? 6. Okay, out of what? You know that you roll the die, 2 die. So here is 6, and here is also 6. So 6 times 6 give me 36. You remember the counting principle? So I have here the probability is 6 out of 36. So it would be 1 over 6. Because we are rolling 2 die. The table shows the number of students who passed and failed an exam from grade 9 and grade 10. If a student is selected at random, what is the probability the student is from grade 10, given that they passed? Okay, so passed mean grade 9 and grade 10, it's 42 plus 18, right? So the past student, what, 42 plus 18, so 60 student. Now I need the probability that the student from grade 10 is passed. So grade 10 is 42. So the probability equal 42 over 60 divided by 6. So it's 7 here and divided by 6. So it's 7 over 10. If events A and B are in a sample space of a random experiment, and the probability of A equals 0.3, and the probability of B 0.6, and the probability of A union B equals 0.7, what is the value of the probability of A given B? Okay, at the beginning, we know that the rule of the union is A union B equals the probability of A plus the probability of B minus the intersection. And the rule for A given B, the probability of A given B equals the intersection over the probability of B. Now, so I don't have this part. So I could get it from this information. So A union B is 0.7 equals the probability of A, 0.3, plus the probability of B, which is 0.6, minus the probability of the intersection. So the intersection equal to, this is 0.9. So the intersection is 0.2. So I got the intersection equal to 0.2. Now let's apply the rule. Zero 0.2 over the probability of B is 0.6. Cancel. So 2 divided by 6 give you 1 over 3. And 1 over 3 is equal to 0.33. So approximately it's 0.3.